Alright, so today we're going to be talking about central and inscribed angles, and there's a few theorems that basically tell you the relationship between central and inscribed angles and their arcs. So the first one says that the measure of a central angle is equal to the measure of its intercepted arc. Now, what that means is if I have a central angle, so this angle that's made by the center, then the angle and the arc are the same measure. That one's pretty basic as far as those being equal. Then it says the measure of an inscribed angle. So remember, an inscribed angle means it doesn't go to the center, but the angle itself is from side to side of the actual circle. If that's the case, then when you have an inscribed angle, the angle that's made is half of the measurement of the arc. So if I were to say that the arc itself was 100 degrees, then the angle that it makes, that's half, would be 50 degrees. Okay, so the inscribed angle is half of the intercepted arc. All right, then if we have two central or inscribed angles and they intercept the same arc or congruent arcs, then the two angles are congruent. So basically, if I'm looking at a circle and I have a central angle here, all right, so let's look. So if I have a central angle and my central angle here, let's say that this one is 50 degrees, okay? And then I also tell you that I have another central angle, and I tell you that that one's arc is 50 degrees. That means these two angles are congruent. So as long as their arcs are the same measurement or their angles are the same measurement, then the arcs are equal or the angles are equal. All right, and the last theorem is a quadrilateral. So remember, a quadrilateral is a four-sided figure. If a quadrilateral is inscribed, so inside the circle, then the opposite angles are supplementary. Now, supplementary means that it's equal to 180 degrees. So, for example, angle A is opposite of angle B. So, A plus B is 180 degrees. Same thing here, C is opposite of angle D. So, C plus D is 180 degrees. So what we're going to do is we're going to look at some examples, and then you guys are going to practice these. All right, so for our first example, so right here I can see that I have a central angle, and that central angle has an arc, and that arc that's being measured is right here. So they want to know, what is the measure of the arc? Well, the theorem says that if I have a central angle, then my central angle is equal to its arc. So therefore, x is equal to 76 degrees. All right, so for number 2. So for this example, I have two central angles, and the marks here, they tell us, so they both have one arc that's in the actual angle. So they're called angle marks. So these angle marks are telling us that these angles are congruent. So the central angles are congruent. Now, since the central angles are congruent, that means that their arcs must also be congruent. Now, the symbol for congruent is the similar squiggle and the equal sign together. But either way, since these are congruent, that means that the arcs also have to be congruent. So this and this. All right, so if this is 65, that means this is 65. And because the angles are congruent, therefore, that means that x is equal to 65 degrees. All right, now we have an inscribed angle. I know it's inscribed, and because the angle goes from the end point is on the circle and the other end points are on the opposite end of the circle. It goes across the circle. So if it's an inscribed angle, remember, inscribed angles are half the measurement of the arc. So when I look at this, I know that x has to be half of the length of the arc. And remember, the arc is 95 degrees. So if I'm looking at my arc, and I know it's 95 because they told us it was 95. So half of 95, that's going to give me 47.5 degrees. Now, if you feel like you don't, you can't do that math in your head, that's okay. All you have to do is do 1/2, or you can do 0.5 times 95, and that gives you 47.5. All right, so number 4. So this one kind of gives you some indirect measurements. I still have an inscribed angle. So right here, I have this inscribed angle. Now, if you notice, this inscribed angle is going through the center. It's got a diameter right here. So I know that this arc, this whole arc right here is 180 degrees, that whole arc. So if that whole thing is 180, so the whole arc is 180 degrees, we need to figure out what this part of the arc is in green. So how do we figure out this part of the arc? Well, we can say 180 minus 100 degrees, and that gives me 80 degrees here. So this measurement of this arc that we're actually going to be using is 80 degrees. So now that we know that, we have an inscribed angle. And since we have an inscribed angle, we know that the inscribed angle is half the measurement of the arc. So we know that x is half of 80 degrees. So x is 40 degrees. All right, and then the last one we have is a little bit more algebra centered. So we still have these same measurements where we're looking at. So we have an inscribed angle again. So we have this inscribed angle. And we know that the arc of that inscribed angle is 4x plus 17. All right, so if we have these arc measurements, we're looking at the fact that this one and the 7x plus 9 and the 4x plus 7 are half of a circle. So if it's half of a circle, that means it's 180 degrees. So they want us to find the measurement of LNM. So we have LNM. So we're looking for this angle right here. So if we're looking for this angle, then we're looking for this measurement right here. So again, LNM is the angle that we're looking for right here. So I'm going to mark that. And once I mark that angle, I know that that is an inscribed angle to 7x plus 9. But I got to figure out what x is first. So the first thing we're going to do is find x. Now, to find, we know this arc plus this arc is going to be 180. So we're going to set up that equation. So we have 4x plus 17 plus 7x plus 9 equals 180 degrees. All right, we're going to combine like terms. So we have 4x and 7x. That's going to give me 11x. And then we have 17 and 9. So we add those together, and that's going to make 26 equals 180 degrees. All right, so we're going to finish solving that. So we're going to subtract 26. All right, and of course we have 180 minus 26, and we get 54. 154, excuse me. All right, so we're going to divide by 11. And then x is going to equal, so we got 154 divided by 11. That's going to equal 14. So we know that x equals 14. But now that we know that x equals 14, we've now got to figure out, we've got to find that measurement. So we've got to find angle LNM. All right, so how can I find that? Well, I know that I have an inscribed angle. So remember, the angle that we're looking for right here is going to be half of this measurement. Well, I can find that measurement by plugging it in. So we're going to do 7 times 14 plus 9. So we have 7 times 14 plus 9, and we get 107 degrees. So that's the arc measurement. So this is the arc. So we know right here that this is equal to 107 degrees. Well, that's the inscribed angle. So what we're going to do is to find the inscribed angle, we're going to say the inscribed angle is half, and the inscribed angle that we're looking for is LNM, is half of 107. So half of 107 is going to give me 53.5. So the measure of LNM is 53.5 degrees is our final measurement. So yes, we had to do a little bit more to find this one, but pretty easy. All we had to do was solve it, and then once we solved it, we had to use our theorems. All right, so let's look at some quadrilaterals. So for this one, they're asking us to find x and find the measure of PQR. So when we're done, we're trying to find the 6x minus 3. Well, how do we find that? Well, we know that these are opposite angles of each other. So the theorem says opposite angles are equal to 180 degrees. So we're going to set that up as such. So we're going to say 10 plus 6x minus 3 equals 180 degrees, because we got to find x first. So that's going to be 16x minus 3 equals 180. And then we're going to solve it. So we're going to add 3. And then that gives me 16x equals 103. Or 183. So we're going to divide there. And we have 183 divided by 16. So we know that x is equal to 11.4375. Now, obviously, that's not a perfect number. That's okay. But now what we need to do is they want us to find the measurement of PQR. So to find the measurement of PQR, we would do 6 times 11.4375 and subtract 3. So if I multiply that by 6 and we subtract 3 from it, then we get the measurement of PQR is 65.625. Now, they may ask you to round one way or the other, especially on Desmos. If that's the case, then just pay attention to how they ask you to round. All right, so same thing, very similar here. I know that we're trying to find the measurement of PQR. So we're looking for PQR, but in order to find PQR, we have to find x. So we know that these opposite angles, so this S is opposite of Q, so we're going to set those up and they're going to be equal to 180 degrees. Combine our like terms. So when we combine our like terms, we get 21x, and then negative 3 and 7 is going to be plus 4 equals 180 degrees. We're going to subtract 4, and we get 21 is equal to 176. So if I set this up and I divide, so 176 divided by 21, I get x is approximately 8.38. All right, and once we get that, then we're going to find the measurement of PQR, and we're going to plug that in. So we're going to do 4 times 8.38 and add 7. So we're going to do 4 times 8.38, add 7, and we get that it's approximately 40.52 degrees. All right, I did pull some Desmos examples just to make sure that we were okay with those. So these are from the algebra section. I think there was 3 of them. One was in Central, one was Inscribed level 1 and 2, and these are the algebra ones. So for this one, it says that HIG, so the measure of HIG, is 61 degrees. So I do recommend drawing your circles and actually labeling it. Sometimes that can make the difference of what you are putting your items correctly. Now, it says the measure of arc, GH, I know it's arc because it's got a little arc symbol, is going to be 11x minus 27. Now, what we know is that we have a central angle, and if we have a central angle, that means that the arc and the angle are congruent. So since we have central angles here, we're going to set these equal, and with that, we're going to solve it, and then it says round your answer to the nearest tenth. So we're solving for x here. So they don't ask us to find the actual angle because we know the angle and the arc are 61, but we're solving for x. So we have 11x minus 27 equals 61. We're going to add 27. And once we add 27, we get 11x is equal to 88. Divide by 11, and x equals 8. Then we have circle J. They are telling us in circle J that the measure of the arc, IK, so IK here, is 148 degrees. They want us to solve for x if ILK is 6x plus 39. So we have an inscribed angle this time. So remember, when we have an inscribed angle, that's half, the angle is half of the arc. So when we set this up, we know that 1/2 of 48, or 148, is equal to 6x plus 9. All right, so 1/2 of 148, that's going to give me 74, and that's going to equal 6x plus 39. And then we're going to solve it. So we're going to subtract 39. All right, so we have 74 minus 39, and we get 35 equals 6x, and then divide, and x equals 5.